Hi there, today we're going to be doing a video for Geometry, Chapter 4, Section 5, and we are proving triangles congruent, and this time using the methods of angle, side, angle, and angle, angle, side. So much like our previous lesson, we have two new methods to prove that two triangles are congruent. Our first up is angle, side, angle, and the acronym ASA there. It basically states that if two angles and the included side, so the side that's in between the two angles, and we talked about that in the last one with side angle side, that time you wanted the angle to be in between the two sides. This time you want the side to be in between the two angles, so you can see your angle A, angle B, and the side that is in between the two congruent angles. So if that happens in one triangle and they're congruent to two angles and the included side of another triangle, then the two triangles would be congruent. So in other words, if we've got angle A is congruent to angle D, angle B is congruent to angle angle E, then a segment AB is congruent to segment DE, then the two triangles would be congruent. So we're going to use this to prove this guy in our first example. Write a two-column proof. It says given that QS, and QS is a segment right here, bisects angle PQR, so angle PQR is this angle right here. And so if it bisects, that basically tells us that it cuts this angle into two congruent angles. So the part that's missing in my proof, I've already kind of gone ahead and written most of it, but the part that we need to put in step 2 is that angle PQS is congruent to angle RQS. Okay, and the reason for that would be definition of angle bisector, which is what they told us QS was in step 1. Then the second given statement is not PQS, but PSQ. So it is an angle PSQ. So here's P to S to Q. So that's this angle right here. Is congruent to RSQ. RSQ, so that's this angle here. So now those two angles are congruent, and that was given. So I've already got that in my proof. And so the only thing that we need now is that we also have a shared side. So we've got two angles, and this is the side in between them. And it happens to be a shared side between both triangles. So we're going to say that QS is congruent to QS. It's congruent to itself. And the reason for that would be reflexive. And then finally we can say that the triangle PQS is congruent to triangle RQS by angle, side, angle. Put our helmets and call it a day. So now you can try this guy. Again, I've already put in the given statements. This is the part you're supposed to prove. So basically this proof only requires 5 steps, and your job is to fill in 2 of them and their reasons, and of course the reason for 5. So hopefully you can have some success with that one. And then we go to the second, well actually the fourth, because we had side, side, side is the first, side angle, side is second, angle, side angle is the third, and now we have a fourth method to solve two triangles or prove them congruent, and that's angle, angle, side, AAS. And in this case, you have two angles, and the non-included side, which would be the side that's not in between the two angles. So we have here, like before, angle A and angle B congruent, but instead of choosing AB as the segment, we want the segment that's not in between. So it could be either BC or it could be AC. So it could be either one of those options, but it needs to be the side that's not included. And if those two angles and the non-included side of one triangle are congruent to the two angles, the corresponding angles, and the non-included side of the second triangle, then the two triangles are congruent. So again, we're looking for angle, angle, side, so we're going to go from angle to side, not angle, side, angle. Okay, so in this case, we have if angle A is congruent to angle D, and B in turn is congruent to angle E, and this time we're going to go BC congruent to angle EF, then the triangles are congruent, and now we're going to use, we're going to do another proof, this time using angle, angle, side as our example 2. And again, I've already put the given statements into the proof, and you can see all we need to do is figure out what this third step is, the reason for it, and then of course which of the 4 methods we're going to use to prove it. So here we go. It says angle DAC, so we want to find that triangle first. Angle DAC is this angle right here. is congruent to BEC, so BEC is this angle here. Okay, and for the record, we are trying to prove triangle ACD. So the triangle, they're overlapping each other. So you've got this big triangle here, and then ECB is ECB. So you've got this triangle, and then you have this triangle. So they're kind of overlapping, kind of hard to see there. But we also know that DC is congruent to BC, so DC to BC. And again, that's just BC and DC. It's not the entire length. It's just from here to here and from there to there. All right, so again, those two pieces were given. So we have an angle and we have a side. And what we have here now is that angle BCE is congruent to itself. It's a shared angle. So that's going to be reflexive. And what I want to kind of try to do for you is, I'm trying to kind of help you out here. What we have is triangle ACD. So you got ACD. This is ACD. Is this triangle right here, not including this little piece right here. Okay, so there's that triangle. And then they want to know ECB. ECB is going to be not including this triangle here, so it's going to be like this. ECB. And what we already know is that angle A is congruent to angle E. And then we're looking that BC, which is this segment, is congruent to DC, which is that segment. Okay? And then now we also know what I did here is that this angle C is congruent to that angle C. So all I'm doing right here is I'm trying to pull out the triangles from the diagram so that you can see it better. I don't know if that's going to help you or not, but that's basically this triangle here is on top of the other one, but they're both using the same angle C, so it's got to be congruent to itself, and that's why I put reflexive there. So now you can see the angle, angle, side, angle, angle, side. So in step 4, the reason is angle, angle, side. Don't forget your helmets. Pretty sure that I put it in example 1. Yep. So now it's there in example 2, and now you can try this proof. Again, just got to fill in a couple steps there. And then we have one more example using Alex's favorite CPCTC. Corresponding parts of congruent triangles are congruent. All right. So notice that here, this is a word problem in your textbook, and I just kind of extracted the information that was important. We want to prove that the two triangles here are congruent because we know that DE equals 15, and they're asking us to find BC or CB, which is this guy. So if these two triangles are in fact congruent, then if DE is 15, then CB will also be 15. But before I can assume that, I have to actually prove that the two triangles are congruent, and then therefore the segments are congruent. So I'm trying to prove the segments are congruent. So my goal is to first prove the triangle is congruent, and then because of CPCTC, DE will be congruent to BC, and then I'll know my answer for that. Okay, so what we know is just that A is the midpoint of CD, and because A is the midpoint, so here's the midpoint A of C to D, which means that CA is congruent to DA. Okay, and that will be definition of midpoint. Cuts into two equal parts, so we've got the facts congruent to that. We already know that angle D is congruent to angle C, and we know that because they're both marked in the diagram as right angles, so we know that, oops, they should be 2 and 3. We know that all right angles are congruent. And so now we have also that angle BAC. So BAC is congruent to EAD. I get those in the right order. And if you're not sure why that's happening, these two angles are vertical angles. We told you guys to be aware of vertical angles, and so they form an X there. So for step 4, we're going to say vertical angles. And then finally in step 5, we can say that triangle BAC is congruent to triangle EAD. And that's because of angle side angle in this case, because the side is in between the two angles. And then because the two triangles are congruent, all of their parts are congruent. So DE is congruent to CB by CPCTC Helmholtz. So we proved that the two segments are congruent, and since we already knew from here that DE was 15, then it's also true that CB also equals 15, which is what they wanted us to answer in the first place. So that's example 3, and now you want to try this little guy. Remember again that you're going to have to prove the triangle is congruent first, and then you can prove that BC is congruent to DE by CPCTC. So once you have done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.